Just in case you're curious, that is the Baha Men, I believe there. Don't ask me why I know that. That is just something that's stuck in my head over the years. So anyway, we're looking at lesson 4. And again, if you look, it's kind of like, hey, wait a second, haven't we talked about you? Yeah, identifying proportional and non-proportional relationships in tables. But again, we just slowly kind of modify. So it's not just, hey, one day we see it and we move on to something totally new. We see it once. Okay, all right. And then we do a little bit more. We do a little bit more. We do a little bit more with it. So, let's see what we got going on here. This particular case, we are setting up the table. We've decided to walk in a long distance race. Okay, there are 2 teams that can join. Team A walks at a constant rate of 2.5 miles per hour. Team B walks 4 miles the first hour and then 2 miles per hour after that. Okay, create a table for each team showing the distance that they would be walked for the times of 1, 2, 3, 4, 5, and 6 hours. Use your table, answer the following questions below. So, okay, let's start filling some stuff in. We did know that the time was a 1, a 2, a 3, a 4, a 5, and a 6 for the hours. So we were told that we would be using that. So let's fill that in on both the tables. We were told that Team A was going at a constant rate of 2.5 miles per hour. So take a moment, see if you can fill in the first few numbers for the distance. All right, so the first hour, did you say 2.5? All right, and then because it's 2 and it's 2.5 miles per hour, you could just do a multiplication problem, multiply it. That'll give you 5. Again, you can multiply here. That's fine. You could also realize that you're adding on the 2.5 each time because we're consistently adding on a 1 over here. So that's fine. Again, it's your choice. But there's a 10, there's a 12.5, and then your last one should be it should be a 15 in there. All right, so now over here, the Team B walks 4 miles for the first hour. Okay, so 4 miles for the first hour, and then 2 miles per hour after that. So take a moment there, all right. Where are they going to be after 2 hours? Well, the first hour is 4 hours, and then 2 miles per hour after that, we should be at 6, and then consistently 2 more miles per hour. So then we have an 8, then we have a 10, we have a 12, and then finally with a 14. And again, the first was the 4, and then consistently 2 hours after that. So what we're looking at here is for which team is the distance proportional to time. All right. Well, again, if we want things to be proportional, we need what's that word? Yeah, we need a constant here. So if we look at Team A, and kind of the hint is that here at a constant rate of 2.5, that kind of constant, if we notice we are multiplying by 2.5 every single time to get from time to distance, time to distance. So it's Team A is definitely proportional, all right, because we are multiplying by a constant. All right. Now, remember, there's a few different ways of doing this. One, you could just figure out what am I multiplying by each time. And as long as it's the same thing, it's okay. Remember, you can also do y divided by x. Now, we have told you here at the beginning, we're always going to make the first one the x and the second one the y. So if I do y divided by x, 2.5 divided by 1, I get 2.5. Guess what 5 divided by 2 is? 2.5. What about 7.5 divided by 3? Yeah, it's 2.5. So we've got our constant. So there's a variety of ways that we can figure out the particular constants. It just kind of depends what works better in each particular situation. Now let's see what we got going on here. Constant. Okay, well 1 times 4 is 4. 2 times 4, not 6. 3 times 4, nope, not 8. So it's not Team B. The other thing we could do is, again, we could do our y divided by x. And again, we told you that the first one's always going to be x for now. The second one's always going to be y. 4 divided by 1, 4. 6 divided by 2, that's not 4. All right, it's 3. 8 divided by 3, it doesn't matter. Shut it down. It's not proportional. So explain how you know distance for the other team is not proportional to time there. Well, in order for it to be proportional, we need to multiply by a constant. So here we are not multiplying by a constant. All right, and again, that's the key thing. To be proportional, we're always multiplying by that same thing over and over and over again. So at what distance in the race would it be better to be on Team B than Team A? Well, let's go ahead and let's take a look at your table. At what distance in the race would it be better to be on Team B than team A. So you got to kind of find where it ends up separating itself at. What are your thoughts there? What's the distance that you think? All right, well let's go back up into the table here and let's see what we can find. All right, so let's go up there. Trying to scroll up here. There we go. So what distance in the race would better be on team B than team A? Better to be on team B. All right. Better on team B than team A. Well, for the first mile, yeah. The second mile, yeah. The third mile, yeah. The fourth mile, ooh, look, there's a tie. And then the fifth mile, team A. So when's it better to be on team A? All right. We would say before. Let me get to my pen here. All right. Before. All right, hour 4. All right, how do we know that? Explain. Well, okay. Well, what does the table say there? It's because up to hour 4, all right, team B. How do you want to say this here? Team B what? Team B had a farther distance, went a farther distance, and we could say that it went, how about farther? That's fine there. All right. So let's look at part D there. The members of each team ran for 10 hours. How far would each member run on each team? So we can go and we can continue the table there if we want. And again, keep on going, keep on going. Now, this one's nice because it's a constant, so we can just multiply. So 10 hours, and we know the constant was 2.5. So for team A, all right, 10 hours, we know the constant is 2.5. So how far? 25 miles. Now, for team B, we don't have that, and this is why it's kind of nice to, have the constant, because we can just multiply, find it out right away. So one thing we could do is we could come up with an equation to use. The other option is to just kind of continue the table. So what we kind of should notice here is if we want to come up with an equation of what we're doing each time to get to it, and we'll talk about techniques here as we kind of move forward, but observation-wise here, what can you do to 1 to get to 4? Well, don't limit yourself just to multiplication. Notice that you can multiply the x by 2, and then you can add 2 onto it. So let's check it out. 4 times 2, 8. 8 plus 2, hello, 10. 3 times 2, 6. 6 plus 2, there's the 8. So we can come up with equations to use. And again, that's something we'll see later on. If I use the 2x plus 2, I can jump to it right away. We'll just kind of complete the table as we go. That's fine as well. But here we get 22 and then your miles that we're looking at. All right, so let's skip on down there. Part of this is kind of interpreting tables, which is nice. But from what we want you to be able to solve in there, let's get to some nicer ones that we want to see here. So Bella types at a constant rate of 42 words per minute. Is the number of words she can type proportional to the number of minutes she types? Create a table to determine the relationship. And right here, this is look at this, a constant rate, constant. So when you fill in the information, this is the idea of we should realize, wait a second, our formula here is y equals 42x. Now, remember, it's always y equals kx, and k is the constant, and we know the constant is 42. The nice thing about it is it lets us fill stuff in right away, and we can see, all right, we told you the x would always come first right now. The y would always come second. If you plug in 42 times 1, yeah, 42. 42 times 2, that'll give us the number of words there. So, yeah, 84. So we can just plug in to multiply. So this way when we get to the 60, we know we're just multiplying it by the 42. And again, all we have to do is plug in and multiply. This is what we want to get you comfortable doing. All right? So plug it in for 60, see what you get. Did you? A little of that. A little of that, all right, and a little of that as well. So 2,520. So again, they're going to kind of tell you, all right, is the number of words proportional? Yes, it is, all right. And why? Well, you told me that there is a constant, and that's the key thing that we're going to see. So part 6, or question 6, Mark recently moved to a new state. During the first month, he visited 5 state parks. Each month after, he visited 2 more. Complete the table below and determine if the number of parks is proportional. Okay, so right here, I'm going to let you know. I'm going to tell you flat out the answer is no. Okay, and part of it is because there's no constant rate. The first thing he did was he did 5 of them. And then Did he consistently visit 5 parks a month? No. Each month after that, it was 2 more. So if in the first month it was 5, after 2 months, well, okay, the next month it visited 2 more. So altogether, yeah, now we're at 7. All right. And then so it's 3. So then so it's 9. Now again, this is what makes it a little bit more difficult is because we've skipped and we got to kind of go back and figure out what we've actually ended up doing. So how can we kind of figure out our formula here to use, or I shouldn't say a formula, but an equation? Well, one of the things that you can do is realize that it was always a plus what? A plus 5 was added on there. All right, so it was always the 5 that got added on. So you could go, all right, well, this is getting 4 added on, this is getting 5, but that's not going to, I still got to figure all of them out there. Pause for a moment, see if you can come up with an equation to use. Did you come up with something? Did you? And again, this is good, just kind of guess and check, getting used to writing equations out, that kind of stuff. How about this? 2x plus 3. All right, remember, this is your x always, this is going to be your y. Now, again, I can't use the y equals kx because it's not proportional. All right, we know it's not proportional because he did different things for different months. So this is where we have to come up with just a separate equation. Now, again, a lot of guess and check right now. We'll talk about strategies, but for right now, we're just kind of guessing around and coming up with things. So this way, if we look at it there, 2 times 1. All right, is 2. 2 plus 3, 5. 2 times 2, 4. 4 plus 3, 7. 3 times 2, 6. 6 plus 3, 9. Now, again, I knew y was going to equal this. So now, oh my goodness, it's an equation. The number of state parks was the y always. So plug that in. And now we can solve our equation. Subtract 3 from both sides. So 20 equals 2x. Divide both sides by 2. Hello, 10. Now again, can we use guess and check? Absolutely. But guess and check's always not going to work because we're not always going to get crisp, clean numbers. And sometimes the number is going to be so large, it's just not an efficient method for it. All right. So we'll hold on to the last one right there. All right. Make sure, again, we're getting comfortable plugging things into equations. That's the main thing. Plugging things in, plugging things in. Oh, Patrick, yeah. Let's hope. Let's hope you're not thinking like Patrick right now. All right. But again, we'll talk more in class.